Hey guys, very good evening. This is Yogen from Forsk School, and welcome everybody for a day two program on deep learning. And quickly, please confirm if you can hear me, guys. Okay. Yeah, please use yes and no button. That would be easier. Yeah. So Paran, Priyansh, Swati, Arushi. Okay, so a lot of people saying yes through chat window as well. Thank you. So uh, as per the schedule, what we are going to learn today, we are going to you know uh, uh, understand that how you can create ANN, using Keras, right? How you can create a ANN, and what the ANN stands for? ANN stands for artificial neural network. That was there, right? And if you remember yesterday's discussion, guys, our most of the discussion was revolving around neural network architecture, that how a neural network architecture is a layered architecture, and how you define the various layers there, what the input layer is, what the output layer is, what the hidden layer is. And if I start from that point only, so that because we have to complete a couple of more topics and understanding on that part as well, right? So first of all, ANN is artificial neural network. Artificial neural network. Yesterday I gave you uh, a idea around neural network, right? Around neural network. And I told you that this is a layered architecture, right? So to read the data is there, right? So we are giving the input from this. There is an input layer, I told you, right? And the last layer that we have is called as output layer, if you remember that part, right? And in between we can have one or more layers. Those are called hidden layers, right? Those are called hidden layers. So the data is moving this way. Data is read by the input layer, then it goes to the next layer. Next layer does some processing, then it goes to the next layer, and so on. And finally, we get the output. From output layer, finally we get the prediction here, guys. So this neural network, right? This neural network, what you see here is actually artificial neural network. This is known as ANN. This is known as ANN. Now, yesterday we did a lot of discussion, and what was that discussion? So you need to answer couple of questions. What I ask you guys, right? So these layers, in between these layers, all of them are called hidden layers, right? These are called hidden layers we have. And then I told you that every layer, right? Every layer has a set of nodes, right? So in generally we call them as node, but in most of the cases, some literature, call this node as perceptron as well, perceptron. Basically, idea behind a neural network comes from a basically it comes from the working of a brain, actually a working of a human brain. In our human brain there are a lot of neurons, millions of neurons, and a single neuron has no capability to process anything, to take any decision. When lot of millions of neurons attached to each other, like so let's say there is a one neuron, it gets some signal, then it will do something, then the output of this neuron goes to the next neuron, then it goes to next neuron and next neuron, and so right. So this is how the data and this is how the information propagates. If you read about how our brain sees something, so basically what happens that through our eyes, we see some image, for example, let's say, right? Now the eyes capturing a kind of impression of this image, and now this image goes to 5 different layers in the brain, guys. This goes to 5 different layers in the brain, and in the last layer a brain takes the decision that who is in the image, right? Whether it's a cat, whether it's a dog, whether it's someone else, right? So now you can see that basically we are capturing this image, and now the data passing through different layers. So you can call this as an input layer, and then a couple of hidden layers in the brain, and finally this last layer takes the decision that who is into the image. So this is how exactly it happens in the brain. Similar to this philosophy, there is a concept which is called as artificial neural network in computer science world, and this is also used to process the data. And the overall high level architecture that I gave you, right, the high level architecture that gave you this the first layer is called as the input layer. Then you have couple of layers in between, those are called hidden layer, and then finally you have the output layer. And now every layer, right, every layer has a set of nodes. Sometimes these nodes are also called as perceptron. And guys, yesterday I defined that what a node looks like, right? What are the different properties? What are the different attributes of a node, guys? Can you guys name me what the node has? Can some, guys, can you respond to this? That if you talk about a node, what it will have? So now people are saying that node will have a weight, node will have a bias, right? And then a node will have input as well, right? A node will have output as well. A node has one more property, guys. That property is known as activation function. That activation function. And how all these are related? How come they all are related to each other? So here we say that output, right, is equal to this output, right? What we get out of the node, what we get out of the perceptron, the output is equal to input multiplied weight, then adding the bias and passing this data to activation function. That was the relationship we have. And now, after this discussion, guys, I gave you couple of insights around that, what should be the right number of nodes in a given layer. So now you need to answer me that yesterday we were talking about that how many nodes are required in an input layer, right? So nodes in input layer, that is there. Nodes in input layer. Guys, can you answer that? How many number of nodes in the input layer? The number of nodes in the input layer depends on the data set, right? And the number of nodes in the input layer would be equal to number of features, right? Number of features in our data. Number of features in the data that is there. So I was talking about the input layer that is there. So in the input layer, the number of nodes, right, are decided by the data set, and by looking at the data set and finding out that how many features it has, right? Because the number of features will decide the number of nodes in the input layer. So nodes in the input layer are always equal to number of features in the data set that is there, right? And I told you that if you have, let's image, right? And that image is, let's say, 20 by 20. In that case, right, every pixel work as a feature. Every pixel works as a feature in case of image. So it will have in total 400 pixels. That means the number of nodes in this particular case will have 400 nodes, guys. 400 nodes it will have. That is there. Now, after this discussion, I also told you that how many nodes in output layer. How many nodes in the output layer, guys? For that purpose, I gave you that if it is a binary, a classification, if it is a binary classification, that means your data only has two labels, right? Your data only have two labels. In that case, one node is enough, right? In case of multi-class classification, right? In case of multi-class classification, guys, right? The number of nodes is equal to number of classes, right? Number of classes or number of categories. So if your data set has, you know, 5 different unique labels, so the number of nodes would be equal to 5 in the output layer, right? If your data has 3 classes or 3 categories or 3 unique values in the label, because what do you mean by class, or what do you mean by category, right? So what are the unique, categories? What are the unique, labels? So that is there. And now, what happened in case of regression, guys? Can you tell me that if it is a regression problem, how many number of nodes are required in this case? One node is enough into this. So I'm happy, guys. Other guys, a lot of guys are responding. Thank you for that. So one node is enough. Now, along with this, I also told you that how many nodes in the hidden layer, right? How many nodes in hidden layer? So guys, this is not a fixed number at all. I have gone through multiple literatures, right? This, is not a fixed number. Number of nodes in the input layer that you can directly find out. Number of nodes in the output layer that you can directly find out given the problem statement, right? So a rough number, right? The rough number is like this, that you can have, the nodes which are close to this number. So 2 by 3rd of number of input nodes, right? Plus nodes in the output layer, right? Nodes in output layer. That is a rough number. That is a rough number, guys, right? So, and one more thing, the number of nodes in the hidden layer, can never be twice or greater than twice the nodes of the input layer. So this number has to be always lower than or at max equal to twice of number of nodes in input layer, guys. IL stands for input layer. So that is there. Now, one more question can be there, that okay, we got how many nodes are required in input layer, we got how many nodes are required in the output layer, we also got how many nodes are required in the hidden layer. That number is also with us, right? A rough number is also with us. Now what is left? Now the thing that is left, guys, is that how many hidden layers you can have. How many hidden layers you can have, right? And guys, there is no fixed number. right? Again, there is no fixed number that you can only have two hidden layers, or you can only have three hidden layers, or you can have only four hidden layers, right? The number can vary problem to problem, and sometimes, right? And sometimes what happens, guys? Sometimes what happens, guys? If you are having, a more number of hidden layers, your a model become more complex, right? Right. So this is there, right? So if you add, more number of hidden layers, it will have, right? It will have a a more complexity. It will be a more complex, right? So that is there. And now, see, just a minute. I need to remove this guy who is with the name data analyst. So I'm sorry, Mr. Data Analyst. So here you go. So yeah, so he was trying to get access of my system multiple times. So I have to, remove him. So
Who
okay,
was he, sir? What's the name?
I don't know, a data analyst, right? So now, guys, so this number can vary, right? You can have one hidden layer, you can have two hidden layers, you can have three hidden layers. So it will depend on lot of concepts. As of now, I would request that if you are new to deep learning, right, you should not give too much focus on this. And first, we need to learn the basics. First, we need to learn the fundamentals of the deep learning, and then only we can come to a discussion point where we talk about that how many layers are required as hidden layers, right? We'll talk about that later on, don't worry. So this is there. Now, uh, now a couple of things as a, a new for you. So there you have. Uh, okay, so we talked about how many, nodes in every layer that we talked about. Then we need to discuss one more thing, and this time the discussion is around activation functions, guys, right? Activation functions. Isika, let's focus on this part first, then we'll come to that part later on, right? Activation functions, right? There are a lot of activation functions in the deep learning, and if you Google on the, if you Google, you will find a big list there that what can be the activation functions. But I will talk about three specific activation functions that are being used in deep learning, pretty much. So what are these three activation functions? But that doesn't mean that deep learning only has three activation functions. It can have, more than that. The activation function that I will discuss about, guys, one is known as sigmoid activation function, right? The other one is known as softmax activation function, and the other one is known as ReLU, right? That is there, ReLU. I will discuss about these three activation functions one by one, and they are easy to understand, not a big deal around that. So let's first focus on a ReLU. So ReLU stands for rectified linear unit. Or what does it mean? You just need to understand that part. So what it means, guys? It means that if input, let's say that this input is denoted by X, for example, right? So we have a node and X is coming like this, for example, let's say, right? So what happens, guys, that in ReLU, what exactly happens if X is greater than, right, or equal to zero, right? I will say, I think it's better to say greater than zero only. So if x greater than a 0, guys, the output is exactly equal to input. That means output is equal to x. Guys, did you get it? If this value is greater than 0, output is as it is. So what comes in, and if that is greater than 0, you get the same on the output. If x is less than or equal to 0, right? In that case, guys, output is always going to be 0. Is that clear, guys? Is this activation function clear? It's a simple mapping, actually. What is the activation function? It's a mapping, that how the input is being mapped to the output. That is right. And now there is a simple theory in case of ReLU, that if your signal, if your data, right, is positive, right, if your input is greater than 0, your output is equal to x. So what is coming in, the same gets on the output that is there. But if x is less than or equal to 0, in that case, guys, output is always and always equal to 0. That's it. This is there. Somaya Sultan, right? So that is there. This is activation function. Which activation function I'm talking about, guys? I'm talking about a rail. This is the activation function rail. That's it. Okay. Now, what about sigmoid? You know, so yeah, Rohit, it can be anything, but you'll understand more about it later on. So it would be too early to answer your question. So please hold on. I think you will, get the answer on your own if you go through, next, couple of days. Then you will understand that part, right? So, guys, right? If we talk about sigmoid activation function, so basically sigmoid is a probability based, a function, right? A probability based function. So what does it mean? A very, in a simple term, would probability, guys, just see, if probability, and let's say we mark this as p. So if probability is greater than or equal to 50%, guys, if the probability is greater than or equal to 50%, we get 1 in the output. And if probability is less than 50%, guys, we get 0 in the output. That's a very simplest kind of definition I can tell you about sigmoid activation function. So is that clear about it, guys? Sigmoid, right? Sigmoid is a kind of a probability based function. In a very simple term, what I say, if your probability is more than 50%, guys, if the probability is greater than or equal to 50%, right, it has to be, the output has to be 1. And if it is less than 50%, it would be a 0. That is there, right? And if you do not talk about in terms of percentage, guys, you can say the probability is always between 0 and 1, right? This is there. And now, if your p is greater than or equal to 0.5, we give 1 in the output. If p is less than 0.5, we give 0 in the output. So guys, please let me know that did you get the idea behind sigmoid function, that how the sigmoid function is working, right? And we'll use it, don't worry about it. We'll use sigmoid function and other functions as well, right? Yeah. So, we need to understand that, where we are going to use them. So I'll, let you know about that. So, and guys, there is a one more function that is called as, a softmax. So I will explain that part a little later. But let me give you an idea that where where these are used, where we are using these activation functions. So again, come back to our layered architecture, guys. This is our input layer, right? This is our hidden layer. So let's say this is hidden layer 1, this is hidden layer 2, and this is our output layer, guys. This is our output layer, right? So we have this connection here, right?
Sorry, your voice is not coming. Guys, give us a minute. There seems to be some problem. I think so. We lost the connection, guys. Give us 2 minutes. There was some power issue, guys. Yogenda will be back in 2 minutes.
Hey guys, I'm back. There was some power failure. So just hold on. We are starting just now. Okay. So guys, can you hear me? Please confirm. Okay, that's good. So guys, what we were talking about? We were talking about the activation functions. And after understanding the activation function ReLU, After understanding the activation function sigmoid, I'll discuss softmax a little later, right? Uh, we were, discussing that, which layer uses which activation function, right? So, as a general practice, guys, listen to me. As a general practice, let's focus on this output layer first. Let's focus on the output layer first. And that's very important, guys. You have to understand this concept. Guys, if you are using or you are, using regression or you are trying to solve a regression problem, right? I told you that in the output layer, guys, I told you in the output layer, you need to use one node, right? If it is a regression problem. Along with this one node, right? You do not require any activation function here. So no activation function, guys. Mind it what I'm saying. I'm just talking about output layer, guys. If it is a regression problem in the output layer, you will have one node and no activation function in the output layer. But that doesn't mean that you are not going to use activation functions in other layer. Every layer will have activation functions. So mostly what happens, guys, hidden layers use ReLU as the activation function. So this will also use ReLU, this will also use ReLU. In the input layer, guys, actually input layer is just used to read the data. So we do not use any activation function here as well, right? No activation function in the input layer. Guys, mind it, it would be very difficult for you to find something, this information on the internet as well. There is a lot of confusion actually. So I'm just, giving you the filtered data, filtered information. So what I say, guys, if it is a regression problem, what will happen? In case of a regression problem, we already know that output layer has always a one node, but there is no activation function on the output layer. Hidden layers will use ReLU, and in any case, whether it's a regression problem, whether it's a classification problem, input layer is never going to use any activation function. That's it. This is there, guys, right? Now come to a binary classification, come to a binary classification. What will happen in this case? So obviously now we know that input layer has no activation function, right? Hidden layer will obviously have ReLU here as well, right? Then what about the output layer? So guys, now you know, because it's a binary classification, how many nodes we need here? A single node is enough here, right? A single node is there. And the activation function that we apply is sigmoid, right? The activation function that we use here is sigmoid. And now you should understand that why I was talking about in terms of probability. So let's say you have a binary classification, a problem, and in which you have this input layer, you have this hidden layer, you have this output layer, and this neural network is classifying the data whether the image has dog or whether the image has cat. So it just need to predict whether the image has dog or whether the image has cat. So this is a simple case of binary classification, and here a one node is enough, right? And now, guys, what is the case? So let's say we give some image, and now the output says that I'm 58% confident, right? The output node is saying like this. This is the output by the output layer node. Then it says that I'm 58% confident this is dog, right? So this is basically a saying that we are saying 1 for the dog, right? And we'll say 0 for the cat. So when this probability is greater than or equal to 50%, this node will become high or will give output as 1. And if this is lower than 50%, right? And this will happen in case of a cat, right? So we'll give this as 0. So here, basically the sigmoid function is converting this probability to a finite response, that either it is 1 or either it is 0. That's the simple use case of a sigmoid function, and that's where whenever you have a binary classification problem in the output layer, you always and always use a sigmoid activation function, guys. So guys, is this clear? Is this a discussion on the slide that we were doing? Is that clear, guys, with you? Right, that is there. So Hemant, just listen to it very carefully. That uh, if it is a regression problem, your output layer will have no activation function, right? A no activation function. If it is a classification problem, then we have to think that what activation function is required in the output layer. So guys, if it is a binary classification where output has to be just high or low, or a yes or no, or cat or dog, pass or fail, right? So one category can be represented by 1 and the another category can be represented by 0. In that case, the activation function that we use in the output layer is a sigmoid. And sigmoid just does one thing, right? It does one thing only. If the confidence of the output node and or the probability of the output node is more than 50%, it makes it 1, right? And if it is lower than 50%, it makes it 0. That's it. This is there. Hemant, is that clear now? Yeah. Now, coming to a question which talks about a multi-class classification, right? So now the one case which is left with us is multi-class classification, right? This is multi-class classification. In multi-class classification, guys, now you know how many nodes in the output layer, guys. How many nodes are required in case of multi-class? That is always equal to a number of categories or number of classes in the data, right? So this is there. Now again, guys, no activation function in the input layer, a ReLU in the hidden layer, right? And now let's focus what is here. So for example, there is a problem, and this time we have to predict whether in the image we have car or we have truck or we have let's say a bike. So in this case, guys, we have 3 unique classes, right? A car, truck, and bike. In this case, how many nodes would be required? Because 3 categories are there, we will need 3 nodes here, right? We will need 3 nodes here. And now, when we give some input image for testing and want a prediction from this model, right? That give me that who is in the image. Is it car or it's a truck or it's a bike, right? Then guys, as we are using 3 nodes here and assume that this is for car, this is for truck, and this is for bike, right? And now we are getting the confidence from this node is, let's say, 70 percent, for example, right? And this comes out to be let's say 22%, and this comes out to be 8%. So this is there, guys. Now, so every node has given its confidence. The a car node says I'm 70% confident this is car in the image. This node says I'm 22% confident that this is a truck, and the third node says I'm 8% confident, right? I'm not very much confident that it's a bike, but it says that still 8% chances are there. In this case, guys, now we apply a activation function which is called as softmax, right, which is called as a softmax. And now what the softmax does, it's a very simple, guys. In case of softmax activation function, it will look at the highest value, highest probability, and it will make that highest probability as 1, and rest of the probabilities will become 0. So it becomes 1 0 0. So in this case, the prediction by our network is car, right? So this is, or let's say, softmax says that this is 0 1 0. That means this is the prediction for truck, right? So this is there. And now you have to listen, guys, that why it is different from sigmoid. In sigmoid, guys, we only have one single node. Mind it, right? And now if you want to perform binary classification using, two nodes, right, then it will become a multi-class, right? Then it will become a multi-class. So let's say this is for cat and this is for dog. Earlier we were using this node only for cat and dog, but now we have two separate nodes for cat and dog. In this case, it is again a multi-class classification, and here you can use the softmax. Did you get the difference, guys? So sigmoid is only, with single node, but in case of a multi-class classification, you have more than two or at least two nodes in the problem. Is that clear? Bataiye, please let me know, guys. Is it going good so far with you? Are you guys getting the concepts right? No, Ishika, it cannot be used. No activation function required in case of regression. So guys, is it going good with you, right? It's still, I told you yesterday as well, right? That don't try to, get answer of everything in just one day. It will never be possible. You will mess everything. That's it. You will mess everything, right? So, that is there. So, this is there, guys. Yeah, Vishwajit, we can do that, right? We can use softmax in binary classification. For that purpose, you will have to use two nodes in the output layer, right? That would be there. So Ishika, understand this concept that you are applying sigmoid in the output layer where you only just have one node, right? But we are talking about softmax when you have more than one node that is there, right? This is there. So, again, this, this is again has to be very, very clear, guys. What I told you. Okay, now you need to answer me. What would be the activation function at the output layer, guys, when you are solving a regression problem? No, Yashwant, there is no. Swati Lohia, please correct yourself. I'm talking about regression problem. And I'm talking about that what activation function you need at the output layer. So guys, if you are solving a regression problem, you do not need any activation function on the output layer, but hidden layers will use ReLU activation function, right? That is there. So a lot of people have responded correctly. Okay, next question comes, right? So this is there. Regression means linear, Sajan, right? Now, next question comes to you guys. What activation function is used when it is a binary classification problem? And how many nodes in the output layer in that case? Right? So in this case, guys, if it is a binary classification problem, you are going to use sigmoid activation function and you will need only one node in the output layer, right? This is there. And what about activation function for hidden layers, guys? What about the? It's same. You apply ReLU at the hidden layers. You apply ReLU at the hidden layers. That's it. Okay, now coming to what will happen if you are solving a multi-class classification problem. Then what will be there, guys? What activation function you are going to use at output layer? You're going to use softmax, right? You're going to use so, and don't worry if still there is a little bit of doubt or confusion, right? Don't worry, we will have a lot of problems to solve in coming days, right? I'm just trying to build a concept first, right? I'm trying to solve. Ishika, the softmax is very simple to understand. That whatever number of nodes you have in the output layer, every node will give us some probability, right? And when you apply a softmax activation function, the highest probability will become 1 and rest of the probabilities will become 0. That is softmax. Did you get it, Ishika, now? Right? And how many nodes to use in multi-class, guys? The number of nodes is always equal to number of classes, right? Number of classes in the multi-class. That is there. So as of now, guys, just stick to this principle that input layer, guys, input layer, no activation function, hidden layer, ReLU, right? And as of now, just to start with, just to start the things, and output layer has a little variation. So if you are solving a regression problem, no activation function. If you are solving a binary classification function, sigmoid is there on the output layer. If you are trying to solve a multi-class, then it is a softmax. Then it is a softmax. Is this cheat sheet clear to everybody? Is this cheat sheet clear to everyone? That input layer, no activation function, hidden layer, ReLU. On the output layer, you have to, a little cautious. If it's a regression, no activation function. If it's a binary, sigmoid. And if it's a multi-class, softmax, right? This is there. Rihan, that is not the case. That will never be the case, right? If you go to a certain, a fraction values, you will find the difference somewhere, right? You will find the difference somewhere, right? So that is there. Now, after this understanding, we are left with only one concept in terms of theory, and then we will move to the practical aspect of deep learning. So from today onwards, next couple of days, like tomorrow, day after tomorrow, and after that also, every day 100% practicals only, right? So yesterday and today, these are the 2 days where I'm trying to build your concept, because what I'm trying to convey you, it will take at least 6 months for you guys to, if you go for a self-study, if you go for a YouTube recorded session, if you go for a Coursera, a course, to understand deep learning, it will take at least 6 months for you. I'm just trying to condense all the information and trying to, share with you a simple wording, simple understanding. That is my target, right? That is my target. I know we get a message that, sir, I tried to learn deep learning from so many, platforms, but finally I gave up, right? Finally I gave up and everything got messed up, right? And guys, this deep learning, right? In deep learning, let me share you. Already we have one professor here, Mr. Abhay was there. I don't know if he's still there. Guys, around 100 plus faculties have taken this course, which is free for you, and it was paid for them, actually, right? We charged, from every faculty, we charged 500 rupees in advance, and you can check with any faculty, right? uh, and they were all over India, right? It was not from a specific region. People from NCR, people from South, people from Maharashtra, Gujarat, Odisha, from everywhere, faculties, even from Assam, Meghalaya, the northeast states, we had that. So now, coming to a final concept discussion for today, right? So let's see what goes on. Uh, and everybody, have to understand that philosophy. And that is the crux of deep learning, basically, and that is the crux of, I would say, a neural network. Let's see that. I will try to, explain that concept through. Thank you, Vipul sir. So Vipul Goyal is there. He's professor. Uh, uh, I think somewhere in Mumbai, if I'm correct, Vipul sir. uh, he is in some college NMI MS Narsi Monji, if I say right, Narsi Monji Institute of Management Sciences, if I'm correct. Okay, thank you. See, now we are going to understand one last concept, and that concept is known as backpropagation in neural network. Backpropagation in neural network or in deep learning. So see, guys, what is happening here. Generally, I take an example to clear this concept. So let's say, guys, we are playing a game, okay, and this is a table. So this is the table, okay. So me and my daughter, we are playing a game, and what is that game? So let's see this. So on our table, we have a marble ball here. So we have a ball here. See this, right? And we need to drop it from the corner of the table. So we need to drop it. So we need to drop it here this way. So it has to be here. That is there. So this is my target basically. What is my target? I need to drop it. But how to drop it? That's and that is the game. So guys, I have a couple of cardboards here. You can see. So I have a couple of cardboards here standing like this. So one cardboard here, another cardboard here, and then I have a one more cardboard here. So game is that I have to push this cardboard, which is the first cardboard in the leftmost side. So I have to push it, right? And now what should be the game, and what should happen in during this game, that this cardboard should fall on the next cardboard, and and this cardboard then should fall on the next one, and finally this last cardboard should fall in this way that it should basically hit the ball so that it gets a movement and drops from the table. Now guys, what happens initially, we place these cardboards randomly, right? And then I'm just pushing it. So it just hitting this cardboard and then hitting this, and now this cardboard falls here, a little short of hitting the ball actually. So this is there. Now what happens, guys? In the first trial, I was not able to hit the target. Then what happens? Then I do one thing. I make a little shift of delta x, and now shift this cardboard to here, right? So this is here. And guys, now you can see if I shift this, if I shift this by delta x, now what will happen? Now this cardboard will not able to hit this cardboard because now it has been kept a little far away, right? So subsequently, I need to shift this as well with some distance, right? So maybe let's say this distance is delta y. So we shift it to this as well. And similarly, right, I need to shift this, as well with some delta z distance, right? So this is there. Now, guys, we again make a push. So in the first trial, we were fail. In the second push, we are trying to, so we were fail here. So that is fail, right? Now we are making a push again. Now, okay, it hits this, second cardboard, it also hits the third cardboard, and now this time we are here. So again, a little short of the target, right? So now again I need to make some little adjustments. So let's say this time I make delta x dash and correspondingly delta y dash and delta z dash. So again in this push we were fail, guys, right? So what exactly we are trying to do every time, guys, that based on the outcome, right, and looking at that, are we able to hit the target or not, are we able to match the target or not, we are trying to make changes, right, in these a cardboard's location, right? And finally, in the third push, right, now, I'm pushing this, then it hits this cardboard, and then finally hitting this cardboard, and this time I'm able to hit the ball, and now it will fall. Now it will take a fall. So in the third push, I was able to, hit the target clearly. And now what happened, guys? There seems to be kind of a repetitive process if you see, right? So my data, my push is happening in the forward direction. So this is forward, a push. This is forward propagation, right? And this, in terms of locations, all right, in terms of location, guys, what I'm doing first, I'm pushing the leftmost first, and then it is, propagating this way, this way, this way. But the changes in the location, I'm starting from the rightmost first, right? And based on this, then I'm making the changes in this, and then making the changes in this. So that means the shifting is happening in the backward way, actually, right? The shifting is happening in the backward way, and this activity that we are doing, is called as back propagation. This is called as back propagation. And now, think the same philosophy, right? Now think the same philosophy, what happens in case of deep learning, guys, right? In case of deep learning, you can consider this cardboard as an input layer, you can consider this cardboard as a hidden layer, and you can consider this cardboard as a output layer. And now we are pushing some data, we are pushing the data. Initially, this, all the layers will have a weight, right, which is, a randomly initialized. So what we were talking about, that every layer has a node or a perceptron, and within the every perceptron or node you have weight and vice. So guys, in the beginning of a neural network, in the beginning of a data processing, all these weights and vice are randomly initialized. They start with certain value, and that value has to be close to zero, actually, right? So from around, not exactly zero, but somewhere around zero. It can be positive, it can be negative as well, right? But never exactly equal to zero. See this. Now, guys, you can easily think that this layer has weights and vice, this layer has weights and vice, this layer has weights, and inside every layer you have a couple of nodes. And now what we are trying to perform, we are trying to make a correct prediction, guys. So let's say we are giving an image, right, to this network, and we want to make a prediction whether it's a cat or dog. So we had made a push. In the push, what we are pushing the image. So that is, we are pushing the data, and now it gives us a prediction, right? And now let's say it says it's dog, but in the image, right, actually the image is cat. So this is the real target, this is the actual response that has to be, and this is the prediction by this network, guys. So there is a difference, right? It's not a correct one. So now, guys, what we do, we start back propagation. So we update the weights for this layer first, then we update the weights for this layer, and then we update the weights for this layer, and then again give the image, right? And then again, it says dog. So again, their output is not correct. So again, we do a change in the weight. So basically, we are trying to orchestrate the weights and weights in such a way so that it starts giving the proper response. It starts giving the proper prediction, right? So this process is known as back propagation, guys, right? So now you can see, right? So this is there, right? And guys, this happens in the training phase, right? This happens in the training phase. What happens in case of the training? You already know from machine learning concept that during the training, what we pass on? We pass on features train, right? And features labels train. We pass on this, right? So we are giving the data and we are giving the label as well. So in the training, we are saying that this is the image of the dog, this is the image of the cat, this is the image of cat, this is the image of dog. So we are giving the training data. And now during the training, this processing is happening, because now in actually our neural network knows the right answer as well, right? Because we have given the label as well during the training. So once this training is finalized, that means weights are optimized. Now you can use this neural network to give the prediction for any new image. And that's what happened in the machine learning, right? What you do in the training, you try to figure out the mapping function, right? And that is happening here. By finding the proper weights and proper bias, what you are trying to get? We are trying to get the final relationship, right? So how all these layers work, closely with each other and give the right prediction on the input data. So this is how backpropagation works. So guys, is this concept clear? Ishika Jen, you need to watch the videos of machine learning and AI again from last week. Is that clear, guys? So this is how the backpropagation happens. So what is the backpropagation, guys? Backpropagation is the activity of updating the weights in a fashion so that you start getting the right prediction, you start getting the right prediction on the data. So finally, let me summarize everything in a single image, right? Let me summarize. Okay, one more thing. Uh, to compare that how close your predictions are with the target value, guys, what I say, we just need to have a comparison mechanism, that how we can compare that our prediction is how far or how close to the correct value. For that purpose, guys, we use a function, and that function is known as, guys, that function is known as loss function. That function is known as loss function. So guys, now you can clearly understand that if our prediction is correct, that means the prediction is equal to the target, right? Then our loss would be minimum, right? So we are trying to minimize the loss. So using backpropagation, we are trying to minimize the loss, guys. So now see this, yes, Pawar, you're right. So see this image that will, clean everything, clear everything in your mind. So please, this case here. Can you see, guys? This is our input data, and it goes to the layer. So, it goes to the layer. So you can consider this as an input layer as of now, and then the data goes to the next layer. So only two layers are shown in the image, but it can have more than two as well. And finally, we are getting the predictions here. So you can consider this as a output. So this is input, this is output. As of now, no hidden layer shown here. And now the output layer will give you the prediction, right? And now we have to check this predicted value. We have to compare this predicted value with the true values, right? And to see that how close we are, how y dash is close to y, we have a loss function, right? And based on that loss function, guys, we have to perform back propagation. And during the back propagation process, what we are trying to update, we are trying to update the weights. Can you see, guys? We are updating this weight again, and then we'll update this weight as well, right? So the algorithm that updates the weights is known as optimizer in machine learning, guys. This is called as optimizer, right? So optimizer will look into the loss function, and based on the loss function score, if it is high, it will take that, how he has to update the weights. If it's a less, so whenever it gets the minimum value of the loss, it will stop updating the weights, guys. So whenever we we get the minimum loss, it will stop updating the weights, and that will complete the training of your a neural network model. That will complete the training of your deep learning model. So guys, let me know if things are okay to you so far, if things are okay to you so far, and then I will move to a problem statement where you know so in this image, right, no hidden layer is shown. It is just a pictorial diagram to give you the concept, actually, right? This is how things are working. This is the things, how things are working. So a loss function, it is basically a function that calculates, that how predictions are, are predictions good, or are predictions poor here. That is. So guys, if you understand, in if you were in AI and ML course, right? Do you remember I told you a cost function? I told you about a cost function, right? I told you about a cost function, and if you remember, in linear regression, right? In the linear regression, I told you the cost function was like this. The cost function was d1 square plus d2 square plus d3 square and d4 square divided by this, right? This was the cost function. This cost function has one more name, so we call this cost function as loss function. So basically, loss function finds out the error, that what is the difference between the predicted value and the correct value, right? So this is the responsibility of the loss function or cost function here, that is there. So after having a fair amount of discussion around this, around the background of deep learning, right? Yesterday we started with this, and earlier we had no idea what the deep learning is. So I started with the concept that where you are using a deep learning. So I told you that if your data, you know uh, uh, you know uh, if your data is image data or a video data or audio data or text data, you are going to use deep learning, because with large volume of the data, deep learning models perform better than the machine learning models that was there. Then I told you that how a deep learning model looks like, and then I introduced the concept of neural network, that was artificial neural network. And then I gave you the concept of layered architecture. Then I gave you the concept of
Guys, I think so. There is some again technical problem. Just wait for a few minutes.
gave you the concept of that which layer is input layer and hidden layer. Then I gave, right, and number of nodes in the uh, output layer, and number of nodes in the hidden layer as well. So Ishika, can you hear me now? Sylvester sir, can you hear me now?
Yeah, there was some problem, I think so, sir. Now it's better.
Okay, I moved. I shifted from my personal data to Wi-Fi now.
Oh, okay, okay.
So Ishika, is that clear? Is audio okay with you now? Vishwaji, don't worry. I'll talk about that topic one more time. maybe tomorrow in the beginning of the session. Don't worry. So even if you get some part of it, that's okay. I'll just repeat it again. Right. So when you repeat something, you know, after a break, things become much clear. Pawar, as of now, just let's focus on the next things. I'll discuss that part. Maybe tomorrow. Now, uh, after that, guys, I told you about the nodes, right? And I told you about that activation functions as well. I gave you the idea that which activation function has to be applied on which layer. So input layer will have no activation function. Hidden layers will have a ReLU. Okay, it is not a thumb rule. It is not a rule that hidden layer can always have a ReLU only. You can apply other activation functions as well. But in most of the cases, while solving real problems, what I have seen, people apply ReLU only because that is the most simple activation function and effective yet. This is effective as well. So we'll also stick with the same philosophy that whenever we have a hidden layer, we will apply a ReLU activation function, right? So that was there. And I then talked about the sigmoid and softmax as well. So I just summarized everything. And then finally, we talked about the back propagation. So Ansuman Sahu is saying, sir, thank you, sir. Thank you very much for providing this level of simplicity to understand better. So thank you, Ansman, for that. So I hope everybody is also getting the same, feel what you are getting. uh, so, now let's, see. Sojit Dondapati saying love from Telangana. So, yeah. So now, see, uh, now let's start, uh, moving to the practical aspect of deep learning now. Now we have to understand that how we use, deep learning in a problem solving. So let's understand that part. So guys, first of all, I will explain you, right? First of all, I will explain you that, which tool we are trying to use, Yeah, thanks, Gaurav. So now everybody is sending, love. So someone saying love from Pune, someone saying love from India. Okay. So I'm in India only, Bharat. So so just guys, let's understand which tool we are going to use. That is really important to know. So guys, the tool that we are going to use is Google Colab, and it's a cloud-based tool. You need an internet connection to use that tool. That tool is free from Google. So let's understand that first, right? So on the go to the browser and say Google Colab. Can you see this, guys? Google Colab, right? So I'm searching Google Colab on the internet. Thank you, Sriram, right? Yes, Arjun, you can, right? But I have never used Jupyter Notebook in my experience. But if you are okay with that, you can use that. Okay, now there is a question coming. So Shubham saying, sir, can we use a spider? No, it is not recommended. For deep learning projects, what happens, guys? You will need to install TensorFlow. You will need to install Keras as well. So if you have, let's say 16 GB RAM or so, then it's okay, you can use a spider. But if you are struggling with 4 GB or 8 GB, I will recommend that you should not use your local machine for deep learning project work, right? For a deep learning project work. So Jupyter and Spider, they work on your local machine. And if they work on your local machine, right, there is a dependency on the RAM size, guys, right? So this is there. Now, so Sriram, that's why I said you that please use Colab, right? So now guys, can you see this is the first link, Google Colab. So let's go to this link and we'll see, here. Okay, as of now, I'm just saying new notebook, right? So guys, there is a pop-up coming and I am saying new notebook. So I say new notebook, right? And yeah, Shika, you're right. I will tell you, right? I will tell you. Don't worry. So guys, can you see the interface that I see is of a Google Colab, and this interface is very much similar to Jupyter interface. This interface is very much similar to Jupyter interface, right? And see, as of now, you can see the file that would be created on the Google Colab would be saved with this extension IPYNB. IPYNV, right? So this is called interactive Python notebooks. What do you call it, guys? Interactive Python notebooks. And this says untitled 0. Let's say I rename it. So I rename it to a demo, right? And I say season 13, let's say, no? Season 13. See this. So this becomes the name of my file. And now there you see, this is basically, a cell where I can write the code. So I can write the code in Python. Can you see, guys? I'm using print, and then I'm saying hello, right, from Forsk. And when I say run, can you see, guys? I'm clicking on this button, run. And there you can see it is getting connected to the cloud. It is in slicing now. And there you see the output. Can you see the output, guys? Here you can see. You can have one more, statement here as well, print, and you say 2 plus 3, for example. Just simple expression. So here you see. So you can see the output as well. I can close and I can clean this. I can clean this as well. And now, if you want to write the next code in the new cell, what you can do, guys? You can, take your mouse towards the boundary, and as you take your mouse towards the boundary of the cell, you will see two options, code and text. So if you again click on the code, you go to a next cell, and there you can see import math, right, as empty, for example, and then empty dot sqrt, right? So this is there, and then let's say 20. So this is there, guys. Print, and then see. So here you can see this, right? And now if you go to this runtime option, guys, can you see a change runtime type? So change runtime type. There it says which hardware accelerator you are trying to use. So as of now, we are not using any hardware accelerator. We are using simple CPU only, and we can take GPU or TPU. TPU stands for tensor processing unit. It's a specific hardware from Google, and which is even more powerful than GPU. GPU stands for what is the GPU stands for? Can someone give me an idea what the GPU stands for, guys? GPUs are more powerful than CPU. GPUs are more powerful than a CPUs, a graphical processing unit, right? And guys, the guys who are game addict, right? Those guys who play a lot of game and all, right? Do you know they keep additional graphics card with them? That makes the kind of processing, or that makes the a game playing smooth, right? So they use that graphics to render, that use that GPU to render good graphics, actually, right? So you can use GPU as well. So let's say we enable the GPU, right? So this is there, and so see, we are there now, guys. Uh, if you want to see, just a minute. Okay. So this is there. Now talking about what the text is, right? So we are able to understand what the code is. Now if we go to the text, so let me add the text cell. And this is basically HTML editor, right? And I can see this is the demo class, for example, demo class for collab, right? So for a collab. So here you can see. And now if I increase the font, so I increase the font this way, and if I click outside this editor, there you can see, guys, this is the demo class for collab. So it's a kind of a HTML editor. I can have a list item as well. Can you see? I can have a list item as well. So where it is the list item. So I can say, for example, I can say Python. Another I can say machine learning, right? Another I can say deep learning, right? So this is deep learning. So this is how you create list items as well. So that you can see. You can have bullets as well, ordered or unordered, everything is there. You can insert an image as well. So this is your editor. If you double click on this, it will open the editor again, right? So this is how, if you want to make something, italic, you can make it italic. This is there. You can see, the collab has become italic now. So so this is, you can see. So there are a lot of options. So what is good about the collab, that along with the code you can keep some text as well. So that can help you understand the concept and everything. So along with the code you can write your own notes, or you can write your own understanding, or maybe you can have your own image or something like that. So this is there. And now after that you can add a more code as well. So let's say import I say import pandas, because we will need a pandas. So does it is it allowing us import pandas, right? We can import other libraries as well. We can import keras, which is the deep learning library that would be used here. So we see import keras here, guys. And now when I'm importing okay, so that's okay. It is so now behind this keras, guys, it is using TensorFlow only. It is using a TensorFlow. So this is all there, guys. And now maybe you can go to this edit button, and then you can say clear all outputs, right? Clear all outputs. So what will happen? This will remove this output. And if something else is also there, so let's say this output is also there, it will remove everything. So see this, clear all outputs. In this case, you are only left with the original code, right? So that's there. So there are a lot of features. And now question comes, where it is being stored, right? Where it is being stored. Guys, this is being stored on your Google Drive. This file you will find on your Google Drive. So let's go to the Google Drive and see if we are able to get it in our drive. So here we have drive.google.com. So let's open it. And here we have, and can you see, guys? This is the recently, added file in my drive, demo season 13 .ipynb, and this is how the collab files look like. And you can maybe right click on this, and you can right click on this, and then you can do open with, and and with open with you can choose a Google collab. Can you see this? You can choose a Google collab. Okay, now guys, if you want to launch collab from Google Drive, what will happen in that case? So guys, what you have to do in that case, you have to go to drive.google.com, and then you have to click on new. Can you see this? You have to click on new. Here, new, and then go to the more, and in the more you should see Google Collaboratory. And if you click on this, it will open up in the next tab. But if you are the first time user, guys, what will happen? In that case, you will not see this in your list. You will not find Colab on your list. Then what you have to do? You have to go to last and choose this option, connect more apps. So click on this. And there you have to search for Colab. So you click on the search, and then you see collaboratory. There you see, you just click on this, and it would be added, right? It would be added. And guys, after this process, you again go to new, click on more, and then you will find the Colab in your options. So this way, guys, using your drive. Okay. Now question comes. Now question comes that how we will get our data in the Colab, right? So maybe your data is in CSV file, maybe your data is in image format, maybe your data is in a video format. Then what will happen? Where we need to store that data so that we can access that data in using pandas or something else in Colab. So for that purpose, guys, if you want to use Colab for your project work and you have some data, you will need to store that data on the Google Drive itself, right? You will need to store that data in a Google Drive itself. So uh, for that purpose, how we can do this, let's understand this, guys. See, for example, this is my Colab. This is the new file. So first, if I want to read some data, so let's say, guys, this is my drive. You can see drive.google.com. A lot of folders are there. But as of now, I'm into a folder called ANN, right? And there is a CSV file called churnmodeling.csv. How I can access this data, churnmodeling.csv. So maybe if you try to do it this way, that I will do it this way, that I will import pandas as PD, right? As PD, and then do one thing, that PD dot read CSV, and in read CSV, you can specify the name of the file. So here I specify the file name. What was the file name, guys? Churn modeling, right? That was there. So .csv. Will it read the data? Will it read our churn underscore modeling.csv? So let's see if that works, right? So now it says, let me run it. And what it says, file not found. The file was not found. Why it was not found? Because the file is available on the Google Drive, and it cannot directly access that data from the Google Drive. First, you need to connect your Google Drive with this Colab, and this process is known as mounting the Google Drive. This is known as mounting the Google Drive. And how you can mount the Google Drive? And for that, you need to have some, a code for it. So I will, use that code. So I'm using that code. Can you see, guys? This is there. Can you see? From google.colab import drive, right? And then I'm saying drive.mount. So if I run this, see this, guys. If I run this, then it gives me authorization code. From where I will get this authorization codes, I need to click on this link, which is coming here. So I click on this link. This link gets open in the next tab. There I will get a authorization code that will connect my Google Drive with the Colab. So I'm using, this email ID, forsklabs@gmail.com. And now, see, when I click on this, right, I need to say allow. So I allow. Then it is the that code. So I just click on this and I will copy it. So I copy the code, and now I go back, right? Yeah, Jeevan, you are right. I go back, paste that authorization code and hit the enter button, guys. Now it is just authorizing, it is linking, basically it is linking my drive with this collab that you can see. So can you see, guys, we got a message mounted at this. And now we need to check, right, that what we have on our Google Drive. So for that, we are doing import OS and then os.get cwd. We want to know what is our current working directory, cwd. So it says that you are right now in the content drive folder, right? If we are in the content drive using ls command, we can get to know what are the files in subfolders under content, and then we see the drive. So basically this is our Google Drive, right? And now, guys, to access the data which was in the ANN folder, right, which was in the ANN folder, can you see this? Let me close this. So which was this CSV file? So what I can do to access this CSV file, I can change my directory to this location. So how we can change our os.chdr change directory. So I'm saying right now I'm in the content drive, but I don't want to remain in the content drive. Let's move on to ANN folder. So how I can specify that path? That move from content to drive, then to my drive, and then finally to the ANN folder. So guys, this is the way you can specify the path of any directory in which you want to access the data. So guys, I'm just changing my directory, and now you will see what is. So earlier my current working directory was coming this content, right? But if I check what is the current working directory right now, so what I can do, os.get cwd, right? So now it will give you that right now you are into this folder, and now I can read. And can you see, guys, I can read this CSV file. And now, guys, this variable, this object is data frame now, right? And if I hover my mouse on this, right? If I hover my mouse on this, it it gives me that this is a data frame with shape 10,000 comma 14, means it has 10,000 records and 14 columns. It has 10,000 records and 14 columns. So if you want to see that CSV file, here we have CSV file. Sajan, this CSV file would be shared, will come with the problem statement. If you are trying to solve a problem, you need to have some data. So, you will find the data. So if I click on this, guys, John modeling, here we have the problem statement for us. Here we have the problem statement for us. See this. Jessica, please watch the video again, after the class. So now, see, guys, this is the CSV file we have. And in the CSV file, we have couple of columns. Can you see, guys, row number is there, right? And customer ID, surname, credit score, geography, gender, age, tenure, balance, number of products, has credit card, is active member, estimated salary, and exited. In the exited, either it is written 0 or either it's written 1, right? So Sriram, you can do that, but that's not as advisable, right? A couple of libraries are for that purpose, but not a very good practice. So see this, guys. Now, what the data is all about and what we need to do and what problem we have to solve. See, guys, this data is from a banking, industry. This data is from an Australian bank, right? This data, is from an Australian bank, and it is, telling, the bank is telling that we have so many customers, right? And this is the customer ID. This is the surname. This is the credit score. This is the geography. This is the gender. This is the age of the customer. This is the time, how long they have been operating this account. So someone opened 2 years back, someone opened 8 years back, and so. And then, what is the kind of current balance, how many products that customer using. So is it using ATM card, he is using the credit card as well, does he or she has some loan as well from the bank. So they are referred to as products. And has credit card or not, is active member, like he's regularly operating the account or not, what is the estimated salary. So all of this data is there. And now in the last column, that is exited, guys, everybody has to listen carefully. In the last column there is one information in form of 0 or 1, which says whether this a customer has left the a bank or not. If 1 is written against this, that means the customer has left the bank. If 0 is there, that means that customer is still with the bank. So now, guys, using this data, we want to make a model which can predict, right, which can predict about a customer, whether the customer will leave the bank or not. So guys, based on customer ID, based on surname, credit score, geography, gender, age, tenure, balance, number of products, credit card, active member, salary, based on this data we have to predict whether the customer will leave the bank, right, or will continue with the bank. So when I say leave the bank, means he will close the account with the bank. So guys, in this data set, can you tell me which one is feature and which one is label? What are the features and which one is the label? What we need to predict? We need to predict this last value, column value, 0 or 1. So if 1, that means the customer, if we predict 1, that means customer will close the account. If we predict 0, that means he will continue with the bank. So guys, what is your say? What do you think? What are the features and what is the label in this case? So in this case, guys, exited is label, right? Because we need to predict this, right? Exited. That means exited is label and rest of the columns are features, right? Rest of the columns are features. So remaining exited is label and rest of the columns are features here. That is there. So now, guys, after this understanding, we go to Colab again, right? And there, we print the data set. So we are just printing the first 5 rows. So when I say dataset.head, it will only print the first 5 records out of 10,000 records. So here you can see, just printing. Can you see? This is the row number. This is the row number. This is the index given by pandas. So this is the first column. This is the second column. This is the third column. This is the fourth. This is the fifth, sixth, seventh, eighth, ninth, 10th, 11, 12, and 13. And then you have, exited column. So can you see on the axis? Now, guys, for simplicity, right? For a simplicity purpose, what I will do, I will not count this row number. I will not count this customer ID because this is system generated. And I will not count the surname as a feature. Guys, mind it what I'm saying, because they are really not important in terms of decision making process, right? So I will drop this column. I will not count it. I will drop this customer ID data as well because that was system generated. And I will remove the surname part as well. So what I will count as a feature is credit score, geography, gender, age, tenure, balance, number of products, credit card, active, estimated salary. So these all are features. So starting from index column 0, column index 0, can you see? I will drop this column index 0, I will drop this 1, I will drop this 2. So I will not count 0, 1 and 2. I will start directly from 3. So this is index 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10, this is 11, this is 12, right? Estimated salary. So to include, to read the features, to separate out the features from this data, guys, right? To separate out the features from this data, what I can do, I can use dataset.ilog. And now in the ilog method, what I specify, guys, in terms of column, I'm saying 13, 3 column 13. That means start from column index 3. And what is the column index 3, guys, that you can see? It is credit score. So, and go up to 13, but 13 would be excluded, so it will go up to 12 only. So 3 column is starting from 3, 4, 5, 6, 7, 8, 9, 10, and 11, and 12. And last column is our label. So this process is very similar to what we used to do in case of machine learning as well. Can you see, guys? This is there. And now you can see that now we have features.shape. So I can do this features.shape, guys. Here you see 10,000 rows and 10 columns, and I can print the features as well. So here you see, guys, features, and here we see features. Okay, can you see? Can you see, guys? This is the first record. This is the second record. If I just want to see the first record, how I can specify this? Using this, guys, I can say 0, right, comma, colon. So this way it will print me the first column only. See this, guys? 1619 France, so this is the, so this is there. Can you see, guys? All the columns are numeric, but 2 columns are having text data. Can you see this, guys? In any algorithm, in any machine learning or deep learning project, guys, we need to handle this kind of data. The data has to be numeric format only if you want to perform some training on the data. So guys, as a next step, we will have to convert this text data, which is about geography and which is about gender. We will have to convert this text data to a numeric format, right? So label means dependent variable, Dhruv. Features mean set of independent variables. So guys, as of now, we have in the last week, if you were part of that last week program on the AI and ML with Python, in our case, the data set were always used to have float or integer values, but this time we have got 2 columns. And guys, do you know what would be the type for these columns? The type of these columns would be what? Do you remember that Python code where we say, for example, data, what was the name of our data frame? What was the name, guys? Data set, right? So data set dot d types, right? Data set dot d types. That was, yes, a lot of people have responded. And see this, guys. The surname is object, but we removed it, right? So these first 3 columns are not used by us anymore. So we are using these from here to here, guys. We are using this. So from here to here, everything is feature. So this is feature, and the last one is for label. And here you can see, guys, geography is object, and that means it's a text data. So now, guys, tomorrow we'll start from this only. First, we will understand that in machine learning or in deep learning project, how you can convert your text data into a numeric format. So that would be the concept that we'll learn first, right? And after that, guys, we will, do couple of more things, right? And finally, we'll start using Keras. Can you see, guys, from there, after that pre-processing activity, we are starting with the Keras, we are creating our own ANN, we are adding our own layers, right? A hidden layer, output layer, and all, right? And then compiling that data, then fitting the model, then performing the prediction, everything will happen, but that will happen tomorrow, guys, right? And there is a question from Ravi. It is saying, sir, why you are not using first three columns? I'm not using row number, customer ID, and surname for my training data because they are not really important. Why? Because surname hardly affects the decision whether I should close the account or continue to operate the account. Similarly, customer ID and row numbers, they are just the data, which are system generated, right? They are not specific to us. They hardly, give any detail about the customer behavior, right? So that is there. And guys, for your practice, you can, find, you know, guys, Siddhant, I'm not dropping the geography because I need to make you understand something important. And that will only happen if I continue with this column. There is a very important learning, because this is a text data. So I want to show you that how you can handle the text data in case. So yeah, Hemant, you can do that, right? So uh, uh, now, guys, that comes with the practice, Fajan. So now, guys, the CSV file, Dr. Sylvester, can you upload the CSV file on the Google Drive?
Everything is uploaded, sir.
So guys, the CSV file is already uploaded. So what you can do, you can copy this from this folder. You can copy the CSV file from our drive and copy this on your Google Drive so that you can start using this, while practice. So guys, that is the end for today. We'll finish off the rest of things tomorrow. And in half section, we will finish this. And the next half section, we will talk about computer vision. We will talk about CNN, Yeah, Bharat, you can do that, but that's not advisable. Thank you, Abhay sir. Faizan, this time I will recommend that no, Jeevan, we will use something else, right? So guys, tomorrow we will finish off our ANN part and start with the CNN as well, right? So guys, please share your feedback. How was the day for you? How was your learning, guys? How was your learning, right? Yeah, Sovic, why not? You can do that, right? So now a lot of people are saying, so it was good. Okay. Okay. Sarjan is saying, sir, Zoom is China's app. You don't you use don't use I don't know. So okay, guys, let me clarify something around that. Lot of people, right? Lot of people in India, they believe that it's a Chinese app. First of all, this is not true. Companies, other big companies who want to make a market into online meeting space, right? They are trying to run a negative campaign around Zoom. Zoom is a company registered in United States. It's a US company, but there is a guy from China who shifted many years back to US, and he was one of the founder in this company, and he is still a US citizen. He is not a Chinese citizen anymore. So guys, this is not a Chinese app, first of all. And that's why government of India has never banned this app, Zoom app. Never banned. They have banned TikTok, those, those TikTok stars, right? Everybody is banned now, right? So guys, I think you should be very clear now. Zoom is not a Chinese app, right? So that should be very clear with everyone, right? Yeah, Viswajit, that's very, we can extract the data from image and audio. So currently around 10 team members in the Forsk, guys, let me explain this. Currently, around 10 team members from the Forsk. Couple of them are very senior, couple of them are junior, and couple of them are freshers. They are working on a project, and in that project, they need to extract text from the image. They need to extract text from the image, and this is a project they are doing for a Japanese company, and really interesting work. So Swati saying very interesting and fruitful, sir. Superb. Okay. So Sriram Potla is saying, sir, ANN is particularly used for numeric outputs only or for images and videos. Guys, ANN is the backbone of every deep learning project, and that you will come to know by tomorrow or day after tomorrow. I'm trying to compile each and everything for you, but you need to be a little patientful. Otherwise, everything will get spoiled, right? So please, have a trust in me. This is my request to everyone. Please have a trust in me. I will take you through the entire journey, and by end of this week, you will get everything very, very clearly. Don't worry about it, right? So Ansuman saying it's awesome class that I ever had before. Pratik Mane saying it was good, sir. Sarjan saying Microsoft Teams is good. Yeah, Sarjan, you can, people are using that as well. Arushi Kataria saying it was really great, sir. So what project can we make using deep learning? पहले समझ तो लीजिए आरुषि जी कि deep learning है क्या. उसके बाद projects के बहुत सारे ideas आएंगे आपको. Don't worry. But कुछ दिन आप, please wait for a few days, and then you will have a hell lot of ideas what you can do around deep learning. So Ashi saying it was really amazing, sir. Got better clarity of the topics, right? No, Kanishka, back propagation is the only way here, right? Uh, Somaya Sultan saying, so really like the way the way of your family teaching. Thank you. Uh, so Ranjan Maharana saying, but sir, Zoom is not end-to-end encryption. It hardly matters, Ranjan, what personal data is being used. Are you sharing any personal data on this, right? And whatever we are discussing, it is already available on the YouTube, right? We shared this data on the YouTube as well. So Kavya, I will let you know. Don't worry about that. Just Uh, so okay, Swati, I just changed. Can you see it now? Is that okay, Swati? Now, okay. See this. So that's yes, Sajid, you are right. That is OCR only, right? So Savik, I will answer that question. So Savik is saying, sir, how did the name Forsk came? Forsk come? So Savik, thank you for asking this question. Basically, Forsk is a Danish word. And the Forsk means research. Actually, Forsk means research. It's a Danish. It's a Dutch word. Savik, and Dr. Sylvester initially, proposed this name, and then everybody liked it. And then actually, in everybody, it was me and him only. So that is there. And Himanshu Gautam Singh says, is this code available on the drive? We'll share this code.
It's already there, sir.
Yeah, it's this code is already there on the Google Drive, right? So Dhruv Garg, I think it's better you go through the machine learning lectures. Praveen Kumar Singh, as usual, the session was smooth like butter. We enjoyed it. Yes. Pavan saying, I have trust. Yeah. Bharat, we'll talk about projects. Bharat, don't worry. Bharat saying, I'm loving the class. Okay. So why not, Bharat? You can make career in AI/ML, right? Kirti, this file is available on the Google Drive. You have the link to that drive now? This is there, right? Anshuman saying, sir, if I get a job as a data analyst, I will definitely try to meet you. Thank you, Anshuman, for that. Uh, Arushi Katari, I will talk about loss function again tomorrow. Don't worry, right? Yeah, Bharat, you are right. Ishika, as of now, season three, project season three has no relation with the DL. It is that project is on data analytics and visualization, right, Ishika? So, yeah, Bharat is saying feels like finishing masters in AI. Yeah, that is there. Avinash Subramaniam saying, so what is feature extraction? Okay, I'll talk about Avinash that tomorrow. Please ask this question in the start of the session only. Avinash, right? So basically, Kirti deciding that which feature to use and which feature to leave, right? This process is known as feature selection, right? This process is known as feature selection. So this comes with quite a lot of practice actually, Kirti, right? And by just looking at the data, you can say that this feature is really important and this feature is not. But over the experience, over the time, you get that kind of understanding. In the beginning, it's a little difficult, right? But after that, it becomes a very normal. It comes through project working, right? If you work on more projects, you get the more understanding around that. That's there, because that will keep on changing, Kirti, project to project. There is no fixed formula to that, right? So which feature to keep and which feature to that would be there. Sriram Potla saying, sir, I'm requesting you to plan a session on data analysis. So we will keep a session on data analytics in September, Sriram. Arushi, I think better. Ayushi, were you in machine learning class last week or any earlier season? Have you ever attended any machine learning class from Forsk, Arushi? Oh, Bharat, thank you. Hmm. Afreen, assignments are just optional. Sincerely attend the classes and that's it. Arusi, and that's why you may face a little problem here. So what I would suggest, Arushi, please quickly go through initial one or two videos. They are available on the YouTube. You can search machine learning season. So just go through one or two or maximum three videos. There I have explained everything, what the feature is, right? Yeah, Bharat, you can. What the feature is, what the label is, right? So that will help you. Otherwise, as of now, I can assume that you are finding little difficulty in that part because you are directly jumping directly from analytics to deep learning, and in between you miss that ML portion. That's why you will have a problem here. Easy. So you can go to the fast coding school and then go there. Bharat is saying, sir, I want to connect you on the LinkedIn. Okay. If you want to connect me on the LinkedIn, it is all for all the guys. This is my link. So can you see, guys, here? Here, this is my Chrome and LinkedIn.com. So here, just a minute. So Ganesh, if you want to convert your IPY NB file.py, that is very simple and easy. What you can do, Ganesh, you can go to the Colab and go to the file option, and there you will see a option download as py, right? So you will see download as py. Can you see, Ganesh? Download.py. So it will automatically convert your ipynb to .py, right? So that's there. And guys, here, this is me actually. So uh, here I copy the link to you. Just hold on. So this is me. Here I get the link for you. So I think that should be okay. So here I get it. Control C, and guys, this is now here. Okay. So in case if you're interested to connect me over LinkedIn, you're welcome. You can make a request, and that's it. Uh, okay, guys. So see you tomorrow, and a lot of things, a lot of new things again in the plate for us tomorrow, and we'll see. So, guys, thank you, and bye bye. Take care. Me too. See you tomorrow at 4 p.m. again. Yeah, Afrin, thank you.